Okay, on page 146. So in this growth, what's the input and what's the output? So this is, we got to keep that straight. That's really what these functions are about, is keeping track of input and output. And all this terminology, right? All this terminology, growth factors, percent change. We need to keep that straight with how that works with the function. Okay, so what is our input into this function? Time, over here, right? And given a number of minutes, the function gives what? What's the output? The mass. Okay, so I'm just going to ignore that middle column. We'll just do it. We'll do it without it because we want to focus on input and output. Okay, and so they said the initial amount was 50. And it said that on the previous page you saw that it doubled every 7 minutes. Is that right? So at 7 minutes, how much would you have? 100. So immediately we have a growth factor. What growth factor do we have? The growth factor equals 2. And which growth factor is that? What would we call that growth factor? He wants the 7-minute growth factor. Agree with that? That's it. Okay, so again, the 7 minutes refers to input or output? That's the input, okay? 7 minutes advancing here. Like that, right? The multiplying by 2, the growth factor is 2, so that's the multiplier. What is the 2 multiplied by, input or output? To get what? An input or an output? Output. That's what we talked about before. So if you advance 7 minutes of input, it's multiplying the output by 2 to get the new output. So again, 7-minute refers to how much input goes by if we multiply a current output by 2 to get that output for that amount of input going by. So what we'd really like here is the 1 minute. So we'd really like the 1 minute. So we'll do that in red. So we want the 1 minute growth factor. Is a little more convenient. So we don't know what it is. Okay, we don't know what that is. So since we have our standard form AB to the x, our growth factor is B, so we'll call it B. So if my 1 minute growth factor is B, how would I get the amount of the mass of bacteria after 1 minute? If I have 50 at 0 minutes and my growth factor, 1 minute growth factor is B, how would I get that mass of bacteria at 1 minute? So the 1 minute growth factor equals B. What would the mass be at 1 minute? What's that? 1/7. Anybody else?
2 to 1/7.
No, so forget what you wrote, all that stuff. The 1 minute growth factor is B, and we have 50 micrograms at 0 minutes. Just with that information, how could you represent the mass at 1 minute? 50B, right? 50B, because that's what a growth factor is. You multiply by B, and it gives you the mass, in this case, 1 minute later, because it's the 1 minute growth factor. 1 minute goes by, multiply by the 1 minute growth factor, you'll get the next output. So I could keep doing that, right? So how many times would I multiply the 50 by B until the mass, so that the mass would reach 100? Right, 7 times. Every minute, once a minute. 1, 2, 3, 4, 5, 6, 7. So if I had the 50 times this, whatever this growth factor is that we're about to figure out, how many times do I multiply that by that B to reach 100 micrograms? 7 times. So 50 times B 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 would be 100. I'm advancing the input by 1 because it's the 1 minute growth factor, and I always get the next output 1 minute later by multiplying by B. So if I multiply by B 7 times, that's B to the 7th. So then B to the 7th equals 2, which makes sense because we could multiply by B 7 times, or we already know we could just multiply by 2 to get from 0 minutes to 7 minutes to get that increase in mass. Okay, to solve for this, we want to solve for B, get B by itself. So what we need to do to this side to get just B? Raise it to the 1/7. So we need to raise both sides to the 1/7 power. That leaves us with just B on the left. So our 1 minute growth factor, some of you said it before, 2 to the 1/7. So if I want to write the function in terms of minutes, so if we want the input to be minutes, and I want the mass after, say, t minutes, what would that function be? So they want you to call that G. That's up at the top of the next page. So G of t equals our initial amount, which is 50. Now here's the key to this. We're going to have lots of growth factors flying around now, even for the same problem. Okay, that's what we said. We could have a 4 minute growth factor, we could have a 7 minute, we could have a 10 minute. So the way I like to set these up, I think it's the easiest, is just have the exponent outside here, and whatever unit that exponent is in, that matches which growth factor you have in the parentheses. So whatever's in the parentheses has to be the same growth factor as what this unit is. So if t is in minutes, then this is the 1 minute growth factor. And we just found it to be 2 to the 1/7. I think that, to me, that makes the most sense. When you start mixing exponents like this, it's difficult, or it's all memorization, to see what growth factor you have. So just bring out the input by itself. Everything else that's left inside will be the matching growth factor for that unit. So if this is 1 minute growth factor, or if this t is in minutes, then that's the 1 minute growth factor. Okay, so how could we find, what's the easiest way now to find the mass, say, after 1 minute? We know the mass at 0 minutes. How can we find the mass at 1 minute? Yeah, so 50 times our 1 minute growth factor. And what do you get for that? So 50.2. Okay, so we said there are many growth factors. Any questions so far? Anybody have a question? So we said there's many growth factors for a given situation. So what would the 4 minute, for this situation, what would the 4 minute growth factor be? What would the 4 minute growth factor be? What's that? Okay, so it would be like multiplying B together how many times? 4 times. To advance 4 minutes, to get the output that corresponds to advancing 4 minutes, it would be like multiplying by B 4 times. Okay, and what is B? B is 2 to the 1/7. So advancing 4 minutes would be multiplying by 2 to the 1/7 4 times. So we can say 2 to the 1/7 to the 4th. And then we could rewrite that as 2 to the 4/7. That would be our 4-minute growth factor. So here's a question. How could you use the 4-minute growth factor to find the bacteria at 5 minutes? How could you use that number to find the bacteria at 5 minutes? So this is to see if you're catching on to what's going on here. How could you use that number right there to find what goes in that spot right there, the bacteria mass at 5 minutes? See if you can do it. Anyone think they got it? What would you do? How could you use this, 2 to the 4/7, to find the mass after 5 minutes? Yeah?
Do 2 to 4/7 times 5.
So he's looking at how much we have at 1 minute, and he wants to multiply that by the 4-minute growth factor. Will it work? Yeah, that's what the 4-minute growth factor does. It gives you the output 4 minutes later. So if you take the output at 1 minute and you multiply it by the 4-unit growth factor, it's going to give you the output 4 minutes later, or at 5 minutes.
You divide it by?
No, they're multipliers, right? Growth factors are multipliers. So I've got the 4-minute growth factor. If I multiply it by what I have at 1 minute, it'll give me how much I have 4 minutes later at 5 minutes. Growth factors are always multipliers. Does that make sense?
So it would just be 2 to the 7? 5/7?
I'm not asking for the 5, that's the 5-minute growth factor. I'm asking for the mass at 5 minutes using that growth factor, which you'd start with the mass at 1 minute and you'd multiply by the 4-minute growth factor. What number do we get for that? Nice and loud.
82.03.
82, we'll call it 82.0. Okay, so we also could have found the amount at 5 minutes using the g function. How could we have used the g function to find the amount at 5 minutes? What could we have done?
Put 5 in for the time.
Yeah, just plug in 5, because that's exactly what this function does. It tells you how much mass you have at whatever number of minutes. Okay, and you should have an image of what's going on there, not just you're plugging in 5, right? You start with 50. If t is 5, then you're multiplying the 50 by the 1-minute growth factor 5 times. Boom, 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 boom. Right? So, not just plug and chug, but you should also see the mechanics of that. What's going on there? Yeah.
Could you have simplified your 5 putting 50 times 2 t to the 7th power? T over 7.
You can, but here's the thing: you can do that. But the problem that arises with that is that when you look at that, can you confidently look at that and say what the 1-minute growth factor is? It's harder to see. Because sometimes you could have t over 7, you could have 3 times t, you could have all kind of expression of t in there. I like this form better because you can just see exactly what the 1-minute growth factor is. It's what's in the parentheses. But yes, they're equal. Okay, questions on this? All right, so then it wants a function called h. Let's do that up here. A function called h that whose input is number of hours. Okay, so same thing again. We'll do it in blue. So if C is the number of hours, we want H of C. Starting value, this is part C, or part E, sorry, part E. What's the starting value? 50? So here's the deal. So now we want the input to be number of hours. So what goes in the parentheses? Not the number, but what kind of thing? Tell me a phrase. What is that in the parentheses if C is the number of hours? Which growth factor? He said it's the 1 hour growth factor. Yeah, that's what it is. So we need to figure out what the 1 hour growth factor is so that every time, for as many times as we multiply it together, it's going to advance the mass that many units. Okay? So how do we get the 1 hour growth factor? We know the 1 minute growth factor is 2 to the 1/7. So should we times that by 60? Divide that by 60? Times it by 60? Is that what you mean to say? We want to times that thing, what? Together 60 times. We want 60 of those multiplied together. Imagine 60 minutes going by. You're going to multiply by that 2 to the 1/7 60 times. So 2 to the 1/7 to the 60th, that will be our 1 hour growth factor, which should make sense because it's just multiplying the 2 to the 1/7 60 times will get you 60 minutes later. Yeah.
Did you say 2 to the 60th over 7?
Uh-huh.
2? Okay.
Yep. Same as 2 to the 60 over 7. And so that's what we want as the 1 hour growth factor. So we could just, because I'm running out of room, let's do that here. Okay, so that didn't turn out great. Let me try that again. So it's 2 to the 60 over 7, that to the c. So that's our function. So every time c increases by 1, we multiply by 2 to the 1/7 60 times. So that's an hour going by, and we'll get the equivalent increase in mass. Okay, questions on these? Does it make sense? Okay, so what I want you to do is, you've got some space there next to number 4, so I want you to work on number 3, but I also want you for number 3, for the situation number 3, to create a table just of input and output. Okay, so just a table that has input and output. You don't need this middle column. In that space next to number 4 as you're working on number 3. So kind of take it a step further than just trying to answer the questions they're asking. You know, explore the situation by drawing the table and maybe talk to the person around you about different growth factors that are possible. Okay, and then I'm gonna, so you can work on that for about 10 minutes or so, and then I'm gonna start a notebook check. Is the task clear? You're doing number 3. You're also including a table in that blank space for number 3 of input and output. So our initial value is 210. If n is the number of 4-minute time intervals, then what goes into parentheses, like you said, is the 4-minute decay factor. So what if it's losing 1/3 of its mass every 4 minutes? What is the decay factor?
2/3.
Remember, the decay factor is not how much you lose, but how much you keep, right? It's how much you keep. So if you're losing 1/3 every 4 minutes, then every 4 minutes you're keeping 2/3. And then remember what I recommended for growth factors and decay factors. Always write them as 1 minus or 1 plus, in this case 1 minus, how much you're losing, right? So 2/3 is 1 minus this amount 1/3 that you're losing every 4 minutes. Okay, so from that we can start a table here. What's the input to this function f? Or in general, what's input? Time, right? Time is input. Time since being 210. Okay, and so at 0 we have 210. So multiplying by 2/3, multiplying 210 by 2/3 gives me which output? How many minutes? If I multiply the 210 by 2/3, it gives me 4 minutes. So if this is number of minutes, not number of 4-minute intervals, so number of minutes. Okay, so then if I take the 210 by 2/3, that's a 4-minute interval, so it's going to give me, is that 140? Can you read that? Yeah. Okay, so because 2/3 is the 4-minute growth factor, if I multiply it by an output, it's going to give me the new output 4 minutes later. Make sense? All right, so now they want the t-minute growth factor. I'll do it in red. Okay, so if we don't know what it is, we can call it B. How many times? So every time I multiply by B, it gives me the output what time later? 1 minute later, right? If I want the minute, the function in terms of minutes, then I need the 1-minute growth factor. Okay, so how many times would I multiply B together to get the same result as the 4-minute growth factor? 4 times. Multiplying by B once tells me how much there is a minute later. So if I do that 4 times, that's going to be equivalent to 2/3. So I could say B to the 4th. Multiplying B together 4 times is equivalent to, in this case, multiplying by 2/3. They're both telling us the output 4 minutes later. So therefore B is 2/3 to the 1/4. So to write the function, g of t would be initial amount, 210. So just stick the t out here. And if that's minutes, then what goes inside the parentheses? The 1-minute growth factor, 2/3, in this case 2/3 to the 1/4. Not timesing it by t. This is the function. We're making a function, so we can plug in any number of minutes, and it tells us the output after any number of minutes. So, so imagine that t was 10. What would we be saying? 2/3 to the 1/4 is the 1-minute growth factor. If we plug 10 in there, we'd be multiplying by 210 the 1-minute growth factor 10 times. And that would give us the mass 10 minutes later. So you have it to the t power because that is how we have the function as a function of the input number of minutes. If you just do 210 without the t, 210 times 2/3 to the 1/4, all you're finding is what? The mass after 1 minute. Now this allows you to find the mass after any number of minutes. You see that? Yeah. Okay, so now we've got 2 functions here, f and g. If we want to find the bacteria present after 3 minutes, is there a better choice, f or g? You want to use the function f or g? G, because n is in what minute periods? 4-minute periods, not convenient. So if you want 3 minutes, you're going to plug what into g? 3. You just plug 3 into g, and you're taking the 1-minute growth factor to the 3rd power, which gives you 3 of them multiplied times 210 gives you the bacteria after 3 minutes. Okay, what about 28 minutes? I want to use f to get the number of, or the mass. Should say mass. I want to use the f function to get the mass after 28 minutes. How am I going to do that? Yeah, because n is the number of 4-minute intervals. If we take 7 of them, that will be 28 minutes. So 28 means put 7 in for n. F of 7. F of 7. Right? Questions on this problem here?
Yeah, I have a question.
Sure.
I'm sorry, for the units, you just put the 3 in for T. Or you change the 1/4 to 1/3.
What is 2/3 to the 1/4? That is our 1 minute growth factor. So every time we advance a minute, we want to multiply by that. So which will it be? So if I put 3 in for T, I'll end up multiplying by that thing 3 times. That's what I want. Yeah, you don't want to change the growth factor. You want to use that growth factor 3 times, which means T equals 3.
Is it wrong to put the 28 into the 1 minute growth factor?
28. No, you could put n equals 28. Or T, I'm sorry. The other way you could solve this is to G of 28. G of 28 would be perfectly fine. Yep. F of 7 equals G of 28. All right, other questions? Okay. So let's kind of summarize this. This is a nice summary here. You're not going to have time to write all this down, so just absorb it, think, answer my questions, and then check out the video. So we said it starts with what we initially called the growth factor. Now we're seeing there's many growth factors, so we're qualifying it as the 1 unit growth factor. Okay? Call it B. So what would the 3 unit growth factor be if our 1 unit growth factor is B?
B to the 3rd.
B to the 3rd. Okay? 10 unit and 16 unit. B to the 10th, B to the 16th. And now we see there's partial unit growth factors. What would the 1/2 growth factor be? B to the 1/2. Not 1/2 of B, right? B to the 1/2. Similarly, 1/8, 1/5. Okay? So if you have the 1 unit growth factor, any other growth factor is very easy to get. That's the point here. And so growth factors are directly transferable. Okay? Once you have one growth factor, getting another one in the same situation, very easy. Okay, but what about percent change? Okay, so we know we can, given a growth factor, we can get its corresponding percent change very easily. So if we had any one of these growth factors, we've had lots of practice getting the corresponding percent change. The question is, do we have some kind of easy transfer between percent change? Okay, is there some kind of nice mathematical link like there is between the growth factors? Okay, so let's do an example to see. Okay, here's an example. Suppose the 1 unit growth factor is 1.25. All right, what would the 3 unit growth factor be? 1.25 to the 3rd, and that's about 1.95. What's the 1 unit percent change? Old stuff, right? 25%. What's the 3 unit percent change? 95%. Okay? So, is there a link? Is 95 3 times 25? How about 25 to the 3rd? Is that 95%? No, wait, that's like in the millions or something, or in the thousands. Okay? So the moral of the story here is we don't have this nice transferable linking system between percent change that we do with growth factors. Okay? So, if the 1 unit percent change is 8.5%, what's the 10 unit percent change? Is it 85%? No. So if you're paying attention, that's what we just showed. It's not. So how could you find the 10 unit percent change? I'm giving you a nice visual here of a way you could find, given that the 1 unit percent change is 8.5%, what's the 10 unit percent change? You do it. Go. So here I am. This is 8.5% here. So the question is, What's the 10 unit percent change? What are you going to find first? Yeah, so to get from this circle to this circle, how are we going to get to that from this circle to this circle? Yeah, here's our path, right? Okay, 1 unit growth factor is? 1.085. 10 unit growth factor? 1.085 to the 10th. Which equals? 2.26. Okay, write it as what? 1 plus, what's the percent increase? 126%. Way more than 85%. Does it make sense? Let's do another one. Any questions on this one? Okay, so if the 3 unit percent change is negative 47%, what's the 1/5 unit percent change? Okay, I suggest that you make a stop along the way. I always do, okay? So don't try to make a stop along the way. So what did I say? 3 unit percent change, negative 47%. And we want the 1/5 unit percent change. Okay, compare with the person next to you. Show them what you're doing. Everybody find someone to talk to. Not an option. Find someone to talk to. Show them what you did. Okay, so we got to get, so hopefully you immediately saw that this is your route, right? That's your route. Starting at 3 unit percent change, we want to go through growth factors, which are easily transferable, to the 1/5 unit growth factor and get the 1/5 percent change. So what is the 3 unit growth factor? 0.53, or 1 minus 0.47. Okay? So then what's the 1 unit growth factor? 0.53? What's that? What'd you say? Raised to the 1/3. Okay? And what's the 1/5 unit growth factor? If that's the 1 unit growth factor, what's the 1/5 unit growth factor? It's the 1 unit growth factor raised to the 1/5. Okay, let's get that number. What's that number? 0.096? 0.96. Okay, 0.96. So what's the 1/5? So that is regarding the exponential growth. What number is that? How much we what? Keep. So to get how much we lose, we take 0.96 is equal to 1 minus what? 0.04. So what percent change do we have? Negative 4% every 1/5 of a unit of input. Okay, you should have started the homework over the weekend. If you didn't, start it tonight. It's not short. See you Wednesday.